So basically we want to sign up with, like final project groups. Why nobody signed up?
No, we're at the bottom.
Yeah, you're right.
Okay. Oh, this is student group.
Oh, wait.
Has anyone signed up this?
We,
You don't
No.
see that.
we,
I think we don't see that.
Yeah. Would you mind showing me what your interpretation is?
I'm gonna see.
well, I don't, mine might look different because I'm on the app.
I'm opening up now.
Oh, okay. Because mine just has the people and then it doesn't have the groups. I don't know if it did before or not.
It did before.
Interesting.
Yes, they are under groups. I can see.
Oh, okay.
They're listed, but I
Thank
didn't
you.
see that before.
So that's interesting, right? So, okay. So I guess if one is on the app,
You have to click groups and then it has a list with the groups.
and also, I mean, you can edit the group name. So, okay.
So we have to go and rejoin a group.
Yeah, because student self-formed groups, I cannot assign the homework score. For example, if I do. So I have to do this, right? So this is a group assignment. I have to tell Canvas this is a group assignment. In order to do that, I can only select the group I create. Okay. Yeah, that's
So we should join one of those 1 to 10 groups.
yes. The final project one. I think you can create your own group in that. Okay. Anyway, so
Should see the English grammar.
there we go. So this is our final project information page. So you submit your report, so there will be a report. So let me go through this. Why the font is so small? It's a little bit better. So basically, we'll have this coding competition. Okay. If you have played something like hackathon, so it's like hackathon but it lasts a month. So how to use Kaggle? Kaggle is like Colab. Okay. Kaggle is a platform that hosts competition. So this is Kaggle. Okay. I mean, this is a homepage, but the real interesting thing is it has various things, that is very useful. So if you plan to have a career related to data science or scientific machine learning. For example, right here, the brand, the Kaggle brand, the most famous Kaggle brand perhaps is the competition. So you see active competition here. For example, the first one is large language model, detect AI generated text. And if you click it, you see this is the host, the learning agency labs. There are like about 1,000 people competing, and the price is about 100,000. And so you can see the leaderboard. So for example, right now, these people, so the top 7 will receive a monetary prize, and the top 12 will get gold medal, and maybe like up to, okay, here. Top 50 will get silver medal, and so you get something like that. And there are other interesting competition as well, not just related to machine learning, but apply machine learning in scientific region, for example. So for example, this October, this competition, I mentored a student. So they have this like annually competition this October. I mentored a student 2 years ago, participate in this competition. So it's pretty interesting. Like so this one I also participated a competition hosted by Stanford about this RNA folding 3 years ago to find the candidate of the messenger RNA for protein for COVID vaccine. It was pretty interesting. So this is a new one, but it has only 21 days to go. So and this is what competition looks like. You have overview, right? So it tells you what competition is. So this is an Eterna. Eterna is pretty interesting platform about protein and RNA, DNA folding, these kind of thing. So it's like a video game. I think my son plays it, but I don't know. It's pretty interesting. It looks pretty interesting, but so it kind of because people have so much computing power, for example, on their iPad, that goes wasted every day. So why not just playing game and contribute to human race? So it's pretty interesting. And then you see these interface. Okay, so this is a common competition interface. You have data. First, you have your data. Okay. So for example, in this, so there's a description of the data. For example, this train data CSV file, and it has this descriptive. So each column, what does each column do? And so if you have never played with Kaggle, it looks quite overwhelming. So many things. And there are metadata, not just the data, but there are metadata. For example, even a sample submission is like 3.67 gigabyte. So these are the data. Okay. So our data will be pretty small. So, and then there is code. So this is the most interesting part, is people will share their code, here. Okay. So you can filter by hardness, but you can also filter. Okay, you can also filter by most votes. Once you filter by most votes, you'll see some highest voted code that helps you understand the competition. For example, this one. I guess this is like influenza, but it's another disease. Ribonanza, I don't know, but okay. So people spend time writing all these. I'm kind of amazed. Yeah. So so this is like a Jupyter notebook, like we use in the Colab, but it's on Kaggle. Okay. So this is what it's like, and it also tells you what is the input data. So for example, these are your input, and it has an output. For example, this is the output file. And sometimes if an output file has, so I'll show you guys later. This is a log, for example. This is a log, basically is what prints when you run this notebook. And so after a notebook is run, you can check what happens. And here are the seconds, okay? So each notebook has a 9-hour running limit, which makes it about 20 or 30,000 seconds around that time. But we won't use that much, So our model will finish training in perhaps 10 minutes. But so our focus is we'll be able to write our own optimizer to fit a problem we would like to train. So And then you have models. There is no like public model shared by the users. So this model just means someone has a neural network that is trained and they shared it here. Right? It's like sharing some large language model like Llama or Mistral that are open source but closed source for their training purposes. So here are the discussion. Discussion is just like a discussion. Okay. And this is a leaderboard. Okay. So leaderboard has two parts. The first is public. The second is private. Okay. So this leaderboard. So right now you see these people will receive the prize based on their ranking, right? But no, okay? This is public leaderboard. Public leaderboard means, so public leaderboard means this, okay? So Kaggle has a big chunk of data, so they give you, for example, the training data, okay? So most training data is with train labels. All right. So these labels tells us what we want to do with these train data. For example, we may have a label, this sample is a good sample, this sample is a bad sample, you know, or it may tell us some numerical property of a sample. For example, what is the image of this RNA molecule, you know, what is the 3D structure of the RNA molecule, but so this data Kaggle gives us, all right? So this data Kaggle gives us too, that is the test data, that is, we test our model, okay? So we use an optimization algorithm to train whatever model, you know, on these portion of data, and then we submit our answer to Kaggle, you know, to get a score on the test data. Okay, the test data, the label is unknown. Okay, so we train our model based on this, and we get an estimate, or we get an approximation to this, and then Kaggle gives us a score how we did. Okay, but in order to prevent cheating, okay, so right now, so here's an interesting thing. It's about math. It's actually not about cheating. Is the training procedure. Okay, so once you know your score on the whole chunk of data, you can use something called probing, because your score on this test data will reveal, this is by probability, the statistics, the probability distribution of the data, okay? So which gives you some information of the data, even, and the label, even though you don't know the label. But this is about probability, it's outside the scope of our class. In order to prevent this, Kaggle divide this data into two chunks. The test data, you don't know the label. So this chunk is public, okay? So this chunk is private. So this chunk you don't know. You know the private, so you know the whole test data, okay? Most of the time. But sometimes, but in all time, you don't know which is public, which is private, okay? So you train your model, and then it gets scored on the public portion of the test data set, all right? And then in the end, after the competition deadline, so you will be scored on this unreviewed private set of data to give you final ranking. So this is very good practice, you know. So and in our class competition, so we'll have a very similar format. So our end goal after the class competition, you will be able to compete in this, you know, public competition. That, for example, this is research prediction competition hosted by Stanford University. You can put your own resume, you know, if you get a silver medal, bronze medal, top 10%, top 5%. So it will be very good for your resume. And so this is like a competition, and for example, you can have submission. For example, right now, you can't submit. I don't know, but in the end, you can see here, you can select 2 of your submissions. So every day, I believe this one has 5 submissions per day, right? Let me check. Yeah, 5 entries per day, okay? So you can submit 5 entries per day, which means you can submit your model 5 times a day. Because every time you submit, it's a chance to know how it performs on this, test data set. So it's like it gives you some information of the distribution. And that's why it's limited. So 5 entries per day. So we'll have 1 entries per day for our in-class competition, which is more than enough. But you should start looking at the code, and in the end, you may select up to 2 final submissions for judging. So let me show let me show you guys what is the select that this looks like. Okay, let me check this one. So for example, this was the last competition it was almost 3 years ago. So you can choose, for example, you can choose submission. You can see right here. So before you choose, you don't know the private school. Okay, you don't know the private school. So for example, I chose these 2. Okay, you can choose others, but I do believe these 2 are my best school. Oh no, this one is the best. I didn't choose this one, but fine. Okay, I didn't realize that. But you don't know. Before you know, because you can see this one. This is error. So this is a mean sum group error thing. You can see this thing achieves higher score on the public leaderboard, but lower score on the private leaderboard. But you don't know before the result is reviewed. You have to use your data science skill to choose the right one. But I didn't choose the best one, but oh, this one is even better. Oh my god, I didn't realize that. Yeah, I didn't choose this. Yeah. But anyway, okay. It's okay. Yeah, we got silver medal. It's enough for my students to get a good grad school. But anyway, so yeah, but this is an interesting competition. So what I showed. So for example, you can check the leaderboard. For example, so public leaderboard, right? We already moved a huge. So for example, in public leaderboard we are 74. Which is still silver, which is fine. But in the private leaderboard, we moved up like 30-something place.
So I have a question. Like when we submit, can't we see what's the result?
You can see your score on public leaderboard, but after the competition concludes, it reviews the score on the private leaderboard. That will be your final ranking. So this guy was my student many years ago, but right now he's a PhD student at University of Michigan. And these 2, so these 2 were my student, actually co-advised, and right now they are at University of Georgia, but doing something different than pure math. So they're doing machine learning in like these related to biological sciences, which is related to this RNA, thing, which I don't know, but I'm not an expert in biology. So there are lots of competition, and the good thing about this competition is, if one competition closes, there will be new competition. You can see these are new. For example, SendNet, HOA, hacking the what? This looks like some, for example, you have 2 months to go, 2 months to go, and there are some like for example, these competitions have prize money, right? but anyway, so aside from these, you have this learning competition as well, this knowledge. Okay, so you can try these knowledge ones and get your hands on the code. And then there is data set. Okay, so there are lots of data set that, like, there are so many common data set. For example, the UCI machine learning repository. Yeah, right here. Why I can't click that? Yeah, this UCI machine learning, this data set, so yeah, why it doesn't have this, so why I can't click this guy anymore? Yeah, but anyway, so this is a pretty standard data set for, for machine learning or linear model 101. The good thing about it is each data set has code. Okay, so it has all these starter code, but you don't want to read these. You just want to sort by most votes. Okay, so for example, most of the higher voted one are good. Okay, but I don't recommend looking at something with a 3 exclamation mark. Okay, so I would recommend something with a more descriptive, for example, like this feature engineering and feature selection, or this basic machine learning with root 1 quality data. So yeah, and then there is models. So the models is you have various interesting models, not just machine learning models, okay, but lots of other models as well. So some common models, for example, this YOLO, you only look once, and also this mobile net, efficient net. Why is efficient net? I don't know what's this. Oh, object detection, I see. So and then there's others for the generated model and face detection. And there are other general model like ResNet, MobileNet, So okay. And then there is code. All right. The nice thing about this is you can publicize your code. So for example, if you click your work, okay, so people would know how you code, and for example, okay, you can check there is private and public, okay. So right now I logged in, I can view all my private notebooks. All right. So for example, these are private. What does this private means is it's only available to yourself, okay? So for example, so these are only like available to yourself, and these are private, okay? So but in your public profile, but if it's public, okay, so if it's public, people can vote. People can vote. So people can upvote your work if they like your work. For example, you can go to your profile, okay, and you check code. So there are public ones. So for example, I can filter. Let me try to just open a new window. So for example, people will view, so I had around 300 notebook RAM, right? But what people will view is only this, right? So, okay. So this is what people will see. For example, this is a simple neural network from scratch. I prepare for some other classes. So people will see this, and you can, so for example, if you're a student, it's very nice to put these on the resume, So, okay. Also, Kaggle Cloud is free and it's the only thing the only barrier that you can use their GPU is you have to have a cell phone, to receive verification code. Okay, then you can use their GPU. And Kaggle even have TPU, so Google would like to promote their TPU. Okay. All right. So this is Kaggle and more. So there is learn. Okay. I used to design a data science for beginner class back at University of California. I basically copied. So you can see I have this progress bar. I basically copied these. This material to the class. It's so if you wanna know more about Python, you can take their classes, but it's for beginner of the beginner. So if you have done coding for some time in different languages, you don't have to take these classes. Okay. So, but it has some interesting intro to game AI and reinforcement learning. Okay. But there are so because this is hosted by Google, right? So it doesn't have a comprehensive, for example, guides for PyTorch, because PyTorch is made by Facebook. But it has something called JAX. JAX is on the rise. Okay, machine learning library. So I use JAX to solve fluid dynamics equations. But yeah, it's a good library. Okay. So it's a very nice platform. Okay, now let's back to our class. So this is our in-class competition. Okay. So later today, you will get an invitation link. Okay, once you click it, you can join this competition. And it has the same thing, right? But it's only for our class. So it has the same format of the public competition. For example, the one by the Stanford University, but it's the same thing. It's overview. Okay, I didn't add this, but so I put it here. So overview. For example, this is the in-class competition of blah, blah, blah. And the evaluation is basically how accurate our model is. It's pretty simple accuracy. So it's not like those area of the curve, one versus all, those sort of thing. It's pretty straightforward. And then we have data. So our data is pretty small. It's around 55 megabytes. It's not gigabytes. Okay, so, and it's in PyTorch format, so we can load it directly. And so here, and the code is we have a starter, okay? So we have a starter, and there is no models. So you can post in your discussion board if you like, ask questions. So then there is a leaderboard. So in the leaderboard there are two benchmarks, okay? So and you look at the code, you click the code. So for example, okay. So in your interface, so here I see this is edit because I own this, right? In your interface, you will see this will become a copy. So you can just copy and it becomes yours, okay? So, and then it's automatically, so here, so it looks like this because it's wrong. Okay, so here. This is what you will see. Okay. So it's basically a starter code. It has some data explainers, for example. So this is some Japanese hiragana characters, and it has some label. For example, this is 0. This is 1. So 0. So all the characters labeled 0 are the same. These characters. Okay. But they may look pretty different, okay? And what our goal is to write an optimizer for the famous ResNet model. So ResNet perhaps is right now like the computer vision 101 model. You don't have to write the code for ResNet, okay? So in the starter code, the ResNet is already, so this cell is a ResNet. So PyTorch, so this torch vision package has already ResNet implemented. So what we need to do is we only need to specify which one we would like to use. For example, here we use the smallest one, has about 10 million parameters. It sounds like a lot, right? 10 million parameters, but for example, this is architecture. Oh, it's 11 million. Okay. But let's see how much time this this notebook or this runs. I forgot how to check runtime. Logs. Oh yeah, here. It runs about 10 minutes. Okay. So but it's pretty, I mean, primitive. This is just a gradient descent method, right? So here is the gradient descent method is we in the coding lecture we implement the simplest one. Okay, so this interface right here. All right, it's a gradient descent interface using autograd. So for example, this autograd. And here the pipeline we learned in class. Okay. And aside from this training or optimizing, last one is here is, so here is the template for produce a file. So here is we evaluate this model on test set. Okay. So this is not training, and so we have 30,000 samples in the test set, and we want to give a prediction on these test set. Okay. So this test set, okay, you don't have access to these test set, but your model will be scored on these test set. Okay. So and then this is a sample code to produce this CSV file that you can submit. So this np save txt, this command will save like a CSV file. For example, this is output. Okay. So this is like a template. You don't have to change anything. The only thing we have to change is the optimizer. And okay. So for example, and after the break, we will go through like more sample code to guide us how to write more optimizer. Okay. So for example, this ID 1, category 1, this means the first sample is in the category 1 and the second sample is category 0. So this is our prediction. So you can click this submit. Okay. To submit to the competition. If we click this submit, it will grade, right? You have one submission remaining today. This reset in 9 hours, so we can submit. And it's success, so our submission, I mean, yeah, because I tested yesterday, so this is the same thing, so you can submit, right? And then you can select as the final score, okay, so you can select this as final score. All right. So if once you join the competition, you have another interface that is team. Okay. So for example, right now you can change your team name and you can access your team members here. Okay. So you just join using the Canvas group, and you can invite the users by other username. So so this is our final project basically. And after we conclude the competition, which is December 17th, okay. So we're supposed to write a project report. So keep this in mind. So your final project score will not be graded based on how high you can climb on the leaderboard. For example, if there are 10 teams, your team ranked 10 out of 10, you won't get a bad grade if you submit your project report. Okay. So your project report so we should submit a project report together with the code. So this code is worth 10 points. Okay. Sorry, worth 0 points. So what you can do is on Kaggle, okay. Oh, I forgot to show you guys what an editor interface looks like. Yeah, I should do that. So for example, if we want to edit our code, so we'll be given an interface. So we click edit, right? And you guys click copy and edit. Okay. So this will be the interface. You can hide. Actually, you can hide this. Okay. So this is the data. So our competition data is loaded automatically. It's unlike a Colab, you have to load your own data or download your own data to Colab. So right here, if it's a competition, it's loaded automatically. So we don't care about models. And here is what I want to say. It's notebook option. So we have this accelerator. So there are none. None means we use GPU is pretty slow. You can test your code using GPU, but when you want to train a model, you want to use GPU. Sorry, so this none means we use CPU. And if you test your code, you can use CPU, but when you train your model, you want to use these two. And I recommend just use P100. This GPU T4, this Tesla T4 times 2 means you have 2 Tesla GPUs that has a shared memory pool. It's basically, it's kind of testing your code. If you have a multi-GPU code, you can test it here. But this is a best option because P100 is much faster than T4. Okay? And then you have your TPU. TPU is Google's advertisement, but it wants to get people hooked up with this TPU, but GPU still has a better ecosystem. So if you use this, okay, so its quota is 30 hours per week. So it resets every week. And then you can update. You can see all these, for example, it's the same thing. So for example, so you can add, so it has autocomplete as well. For example, you can do this, so, and all these are the same. So you can edit this as well. So it becomes the editing interface of our Colab. So almost everything is the same with Colab, except that the interface is a little bit different. Okay. Oops, something went wrong. Okay. Yeah, but anyway, reload. I don't often get this. I don't know why they have this. So to submit, okay, so let's leave. So to submit your code, what, Kaggle is done? Wait. You gotta be kidding me. Oh my God, Kaggle is really dumb. You gotta be kidding me. I mean, this is kind of rare, right? Considering Google has a, well, okay. So, yeah, what I want to say is there is a button to download the notebook. Okay, so after you run a notebook, there is a button to download it. Oh, it's really dumb. I cannot load it. So there's a button to download the notebook, the IPYMV file. and then you can submit it here, okay? So then our project report is only a 2-page project report. So basically, you want to put a table of your model. So for example, we have 3 models, right? ResNet 17, ResNet 34, ResNet 50, and you want to at least do 2. I mean, it's enough to get you a full score, 10 out of 10 on this report. And so basically, you want to record their training and validation score. So we'll talk about validation when we're back from the break. And okay. So then the second is you want to talk about what optimizer you tried for each model. Okay. For example, the baseline has the gradient descent. All right. So and here this is optional. Okay. So you can basically put up your own conjecture of why you think some optimizer is better, and so basically the essential part to get your full score is these 2. So you have at least to train 2 models with optimizers we learned, in class. Okay. So that's it for today. So I think for final project you want to register for Kaggle first. Okay.
Thank you.
Wow.